Okay, in this video we're going to go through June 2020 AQA paper 2. So without further ado, question number 1. So number 1's looking at identities. Now normally the dead giveaway would be that they've got a triple equal sign, but in this one they've all got a triple equal sign. So what actually is an identity? Well, it's something that's always true no matter what the value of x. So x add 4x equals 5x. That is always true. So that is an identity. Okay, so that's our answer. In this one, 6x equals 18. That is only true when x is 3. If x is 10, 6x is not 18. So that's an equation. And actually the other two are equations too. So actually an identity is it always works no matter what value of x you've got. Okay, number 2. Circle the reason why these triangles are congruent. So congruent means exactly the same shape and size. We've got 5, 20 and 9. So we've got 5, 20 and 9. We've got side, angle, side. Number 3. Circle the number that is written in standard form. Okay, so standard form is a times 10 to the power of n, where a is a number between 1 and 10 and n is an integer. Okay, so we've got the first one is 0.9, that's less than 1, so no. 6 times 10 to the 0.5, close, but 0.5 is not an integer. 5.2 is between 1 and 10, and minus 4 is an integer, so we've got 5.2 times 10 to the minus 4 is our answer. 12 times 10 to the power of 7 is obviously 12 is above 10. Now this one, a is less than minus 1. So let's work these out. Let's say a was minus 1. Half a is minus 0.5. A is just minus 1. A squared, negative 1 times negative 1 is positive 1. And negative 1 cubed, well, negative 1 times negative 1 is plus 1. Times negative 1 goes back to being negative 1. So which one is going to give us the largest value? It's going to be a squared. Whenever you've got a negative number and you square it, it's going to have to be bigger than plus 1. So it's going to, in all cases, be a squared. Okay, number 5. Blah, 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 blah. The time spent watching TV was recorded. Okay, so I've not got the graph in front of me. But what you end up with, if you plot these points, we've kind of got a few points here. If you carry it on, so you plot the missing points, I believe that you end up with a kind of straight-ish line like so. So if you join up all of those, so you've got, I mean, I think I've drawn it kind of a lot more jagged than it is when you plot it, but I've exaggerated it for effect. Okay, so you've joined those up. And then that's the first mark. So it's complete the graph, 2 marks. And it says use the graph to estimate the average daily time for a student in 2020. Well, your graph only goes up to 2019. So what they're expecting you to do is, with a ruler, draw your line of best fit. I mean, that's terrible, isn't it? I wish I could do that again. But you've drawn your line of best fit with a ruler. Okay. And then you need to go from 2020 with a ruler. Go up to where it hits your line and then draw it across like so, and then read that value off there. Okay, so I think, let me just have a look. I think the answer needs to be 70 something. So we're on question number 5. Let's have a look at what they accept. So anything between 70 and 78. Alright, so plot the points, join them up, line of best fit, vertical, horizontal, and then this value needs to be between 70 and 78. Apologies, that is a terrible graph. And I would probably not have got the marks in the exam, but never mind. So, number 6, work out the highest common factor of 75 and 105. Now, what I'm going to do, just know a bit of shortcuts, to be honest. So highest common factor of 75 and 105. What I'm going to do is I'm going to write out the product of prime factors. So what is 75 as a product of prime factors? Well, it's in a calculator exam. So what I'm going to do, just move it over here. I'm going to type 75 equals, and then I'm going to do shift, and there's this yellow word fact here. So if I do shift fact, it gives me 3 times 5 squared, which I'm going to write out in full. If I do the same thing for 105, so 105 equals shift fact, I get 3 times 5 times 7. And the shortcut is for highest common factor, it needs to be in both lists. So we've got a 3 in both lists, a 5 in both lists. I've not now got another 5 in each, and I've not got a 7 in each. So the highest common factor is just going to be 3 times 5, which is 15. Okay, if I wanted to work out the lowest common multiple, I've done exactly the same thing. But I've got 3 times 5. I also need to times it by this 5. And I also need to times it by this 7. So I would just type that into my calculator. 3 times 5 times 5 times 7. The lowest common multiple, not that they've asked for it, would be 525. Okay, number 7. So let's have a look at number 7. Blah, 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 blah. Right, this again, you just got to know what this is. Easiest 3 marks on the paper if you know what you're doing. So what are the roots? The roots are where it crosses the x-axis. So one of them's 2 and one of them is 5. Okay. Part B, what's the x-coordinate of the turning point? Well, turning point, just common sense, is going to be where the graph turns. So what's the x-coordinate for that? Well, it's halfway between 3 and 4, so it's going to be 3.5. Number 8. At a party there are 90 people, 48 are women, 42 are men. So we've got 48 women, 42 men. Okay, we've got 90 people. Some women leave. So we had 48 to begin with, but some go. We had 42 men and some arrived. The ratio is now 10 to 11. Well, if we had, so some women leave, well, 48 to 10, that would make sense. But we have more men than we started with. So it can't have 11 men because it needs to be more than 42. So let's just start building this ratio up. If we just double it, we get 20 and 22. If we just add the same ratio again, we get 30 to 33. Still got less men. 40 to 44. Well, that could work, couldn't it? 48 to 40, the women has gone down. 42 men to 44 men has gone up, so that could work. So are there now more than 90 people? Well, no. That is our ratio now. We've now got a total of 84 people, but we started with 90 people. So let's just double check we've got the question correct. Are there now more than 90 people at the party? No. Now 84, started with 90. Okay, you don't need to start writing essays, just get to the point and write the fact. Right, 9. Here's a cuboid. Assume that the total surface area of the cuboid is 200. Work out the volume. So we need to work out what y is. So let's just see if I can sketch this out just to help me. So we've got our cuboid a bit like so. That's 5, that's 5. So let's just put some missing lengths on. Okay, well, we're dealing with the surface area, so let's just be really methodical about it. Let's go with, first of all, that's y, isn't it? And that's y. Let's go with the front and back. Okay, so the front and back, what's the area of this front? Well, it's y times 5, which is just 5y. But that's the front. We also need the back, so I'm going to 5y to 5y is 10y. Okay, let's do the top and the bottom. Okay, so, well, it's going to be the same, isn't it? Because that length is also y. The width is also 5. So, again, it's going to be 5y to 5y is 10y. And all we're left with is the left-hand side and the right-hand side. So, this one is 5 wide, 5 up. I've not drawn it like a square, but it is a square because it's 5 by 5. So, that's just going to be 25. But I also need the left-hand side which is 50. So adding these up all together, we get 20y plus 50, and that gives me my total surface area of 200. So simplifying this, or just solving this equation, you get 150 divided by 20. Always type it into your calculator in a calculator exam. It's not cheating. You're a moron if you don't. You get y is equal to 7.5. Okay, but the question says work out the volume of the cuboid, and the volume of a cuboid is just length times the width times the height. So we've got 7.5 times 5 times 5. Type in that all into your calculator. You get 187.5. What are our units? Centimeters. I'm doing centimeters times centimeters times centimeters. So my units are going to be centimeters cubed. Okay, that's a lot of work. 3 marks. Okay, so that was 9A. Let's have a look now at 9B. So 9B, in fact, the total surface area was less than 200. What does this mean about the volume? Okay, well, remembering from the last piece of paper then, so we had 20y plus 50 equals 200. If it was, so then we solved that, didn't we? We said 20y, I don't know if it's going to help, 20y is that, divided by that, and you get y is 7.5, okay? So then that was then used to work out the volume. In fact, the surface area is less than 200. So if this number is lower than 200, if you take away 50, this number is then going to be smaller. And then we're dividing the smaller number by 20, so the length is not going to be 7.5, it's going to be smaller than 7.5. So going back to the volume of the cuboid, these two are going to stay the same, so we can get rid of those. The length is getting smaller, so you should be able to see that the volume is also going to get smaller. Okay, so it's going to be the top answer is smaller than part A. Okay, 4 marks. So a lot of these questions, you just got to be methodical about it and just try and pick up the marks as you go. So Alex and Bev sat 6 tests, each with 50 marks. So 6 tests, each one had 50 marks. So overall, the test must be out of 300, right? Because I've just done 6 times 50. The table shows their mean percentage after 5 tests. Okay, so out of 5 tests, well, that's going to be out of 250, isn't it? After all 6 tests, their mean percentages were equal in the blah, 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 blah. So well, let's just work out what they've got to start with. So in the tests so far, Alex has got 60% of 250. So 60% of 250. In your calculator, I mean, maths teachers might kill me, but just kind of easy to do it, so why not teach you? So can you see that there's a yellow percentage sign above this answer? So if you just do 60, press shift and get that percentage symbol. So we've got 60%. If I then just times it by 250, I just get the answer straight away. It's just going to be 150, right? Just so easy to do it that way. And then if you do the same for Bev, so Bev's got 52% times 250. So let's just do that. In fact, let's just use the cursors. I'm feeling very lazy. So let's go here and let's say, well, what's 52% of 250? 130. Okay, so blah, 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 blah. After all 6 tests, they're equal. So we want the total marks after 6 tests to be the same. In the 6th test, Alex scores 24. So Alex had 150. He's got 24 in the final test. So he's finishing with 174 marks. Now we know that Bev must get the same amount, right? So if she's got 130, what must she get in the last one? Well, it's going to be 174, subtract 130. She must get 44 in the last test. So, in fact, that's all it is, isn't it? So she needs 44 marks. So if you can use that percentage symbol, it just makes your life a bit easier. It just saves you a bit of time in the exam. Okay, In fact, let me just explain what it is. 60%, all the calculator is doing is dividing it by 100. So some of you would prefer to have just done 0.6 times 250. That's all your calculator is doing. It's just doing 60 divided by 100 times 250. But I would just use the percentage symbol, to be honest. Right. Number 11, density equals. So you just need to learn this formula. Density is mass divided by volume. But the problem here, you just got to be careful with the units. So can you see that in the answer, the units are grams per centimetres cubed? But we've not got grams, we've got kilograms. So you need to work out 1 kilogram is 1,000 grams. Again, a fact you just need to learn. I remember it by saying, well, K in maths is 1,000, isn't it? If you've got 50K in the bank, you've got 50,000. So 1 kilogram is 1,000 grams. So to get from kilograms to grams, you're just timesing it by 1,000. So we've got 2,625 grams divided by 250. Type that into your calculator and you get 10.5. Okay, so that's 10.5 grams per centimetre cubed. Okay, number 12. Work out the gradient. Okay, so a gradient between 2 points. I would always just draw out a rough sketch. So what is minus 2, 3, or whereabouts would it be? Well, minus 2, 3 is about here. And where is 1, 9? Well, 1, 9 is going to be about here. And you know that to work out the gradient, it's the change in y divided by the change in x. So what on earth does that mean? Well, it means what's the difference going up and down divided by what's the difference going left to right. So this one, if we dotted this one down, would be minus 2. This one would be 1. So across, we've gone 3. And this one started at 3 and it's gone up to 9. So that one's gone up by 6. 6 divided by 3 is 2. My line is sloping upwards, so it's positive. So it must just be positive 2. Right, so that's okay. Just draw yourself a little sketch and then you should be okay with it. Number 13. Okay, so number 13, what have we got to go through? Blah, 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 blah. The diagram shows a wall. The area is that. Work out the length of the wall. Okay, so there's different ways that you could do this. What you could do is you could say, well, it's going to be a square, it's going to be a rectangle and a triangle, and you could just split it up into 2 and then add them together. That would be fine. But because these are both right angles, I know that this side and this side must be parallel. So therefore, it's a 4-sided shape. We've got one set of parallel sides. It's just a trapezium. And the area of a trapezium is half, brackets, adding the parallel sides together, times by the height, which is the length that we're trying to work out. So then let's put the information that we've got in. The area is 39.2 equals half of the parallel sides added together multiplied by the height. And now you've just got an equation to solve. So let's start by doubling both sides. So we get 78.4 equals, and let's just do the brackets at the same time, why not, I'm lazy. 2.8 add 2.1 is 4.9. So we've got 4.9h. But we want h, so I'm just going to do 78.4 divided by 4.9, which gives me 16. Okay, a nice round number. And in fact, that's all I needed to do. Okay, so it's just 16, and I should have probably put the units there, meters. Rattling through it. Number 14. Okay, so number 14. A marathon takes place each year. There were 6,500 in 2020. Each of the next 3 years, it's going up by 5%. Okay, so we're increasing something by 5% for 3 years. Does this mean that there'll be more than 7,500 in 2023? Okay, so just doing this kind of in full, we start with 100%. If we're increasing it by 5%, in effect, we've got 105%. But But how do I change that into a decimal? Well, we kind of alluded to it before. What you can do is just divide the percentage by 100. And if you divide it by 100, you get 1.05. And this is sometimes referred to as the multiplier, simply because it's just what you multiply by to go up by 5%. So we've got 6,500. I'm timesing it by 1.05. That's going to be a 5% increase. But because it's a 5% increase year on year, I need to do it to the power of how many years I'm increasing it for. So in this case, it's going to be to the power of 3. Okay, so we've got to type in 6,500 times 1.05 to the power of 3. And we get 7524.5625. Obviously, that's stupid because it's people we're talking about. So you can't have 0.5 of a person or 0.5625 of a person. So this one is going to be 7,524 people. Have we answered the question? No. The question is, does this predict there will be more than 7,500 runners in 2023? So we must answer it. Yes, it does. Okay, number 15. These ones, you just got to practice them, right? There is no shortcut for these. You've just got to spot it. I've done millions of them, so hopefully I'm not going to make a mistake here. But you've got A equals B over C plus 5. First of all, take away 5 from both sides. And then this is the bit that's going to catch you out. Multiply by the denominator. Okay, if you multiply by the denominator, on the right hand side you're just going to be left with the numerator. But I'm multiplying all of A minus 5 by C. So that A minus 5 needs to be in brackets. And I'm multiplying it all by C. And because I just want it to be C the subject, I just want C equals, I'm just going to divide by this whole bracket, so I get B over A minus 5, and hopefully that is the answer. Okay, 16 then. So where are we? 16. Gluten-free meals. Fair enough. So on a restaurant there are 22 main dishes and 4/11ths. So we've got 22 main and 4/11ths of those are gluten-free. Well, let's just work that out. So again, fractions of an amount on a calculator is very, very simple. So we just type that fraction in. So get your fraction button. 4 over 11. Press the right arrow because we're going up there. So 4/11ths times 22 is 8. Okay, so in fact, the top one, we've got 8 gluten-free mains. Then we've got 7 rice dishes. They're all gluten-free, so that's going to be 7 gluten-free there. And then we've got 5 naan dishes. 40% are gluten-free. Again, you could probably do this in your head, some of you. But 40, use the percentage symbol. 40% times 5 equals 2. Right, so we've got 2 gluten-free. I probably should put my working out. 40% times 5 is 2. So we've got 2 gluten-free, 7 gluten-free, 8 gluten-free. It says this meal deal is on the menu. Choose 1 main, 1 rice and 1 naan. How many possible combinations are totally gluten-free? Well, in this we've got 8 mains, 7 rice and 2 naans. So all you do in this case is you just times them together. So it's just 8 times 7 times 2. It's called the product rule if any of you want to go away and practice it. But if you do 8 times 7 times 2, you're going to get 112 possible combinations. Okay, so that is how you do that one. Number 17. Blah, 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 blah. Cumulative frequency, right. So cumulative frequency is okay. Again, you just got to kind of practice these. They come up quite frequently. So we've got X and we've got Y up here. Now cumulative frequencies have this really characteristic kind of S shape. All right. Now there are 200 apples and we want to work out the median. Well, the median you should know is the middle. So if this number up here is 200, the middle one is 100. So use your ruler again to go to the line and down. Make sure those lines are on there. And actually looking at this one, hopefully you should get 83 grams. Okay. Part B. Apples with mass 90 grams or less cost 32 pence. Apples more than 90 cost 39 pence. So this time what you need to do is you need to go up from 90. So this is 83, isn't it? If we go up to 90, draw a vertical line, go across. We want to work out, well, how many apples are there less than 90? Now, importantly, looking at the scale, one big square represents 20, and that's also got 5 little squares in it. So each little square is going to be going up in 4s. So actually, at 90, I think this value here, I've not drawn it particularly well, is 154. So there should be 154 apples less than 90 grams. And how much was it for 90 grams? Well, it was 32 pence, so I'm just going to put it in pounds, 0.32. Type that into your calculator. 154 times 0.32 equals £49.28. Well, the rest must be more than 90, right? So if there's 200 in total, there must be 46 that are bigger than 90 grams, and they cost 39p each. If I do 46 times 0.39, I get £17.94. So if I add that with my previous answer of 49.28, I should get £67.22. Now I just want to check. It's quite a fiddly answer, that, so I just want to check that I've got that one correct for you. And it should be, whoa, what have I done wrong? What have I done wrong? It should be, I've just typed it in wrong, haven't I? 46. I've got it wrong, haven't I? Some of you are going to be on the ball. I just wanted to check because I thought I'd gone wrong. What an idiot. Okay, so what I'd done wrong, I even told you it was going down in 4s, didn't I? This should be 156. So it's 156 times 0.32. This one should be 44 times 0.39. Add those two together, and then you should get the answer, which is £67.08. Apologies about that one. Okay, hopefully that makes sense to you though. I just misread the scale. Okay, and whilst I'm there or talking about that, it's important that you do check your answers. Okay, so go through it, and just at the end, if you've got any spare time, just have a look to see if you've made any stupid mistakes like I did then. Okay, so number 18. This shape is made from 2 right-angled triangles and a rectangle. Work out the size of angle X. So I'm just going to draw the shape out. So we've got 2 triangles like so. This one is 62 degrees. This length is 5. This length is 12. And we're asked to work out that angle there. Okay, so this is going to be a bit of work. So what we need to work out, let's work backwards. All right, I need to work out that angle. And in order to work out that angle, it's a right angled triangle, I need to work out another length. Okay, so if you're stuck on that, have a look at my I've got a triangle but what do I do video. So I need this length here. Well, how am I going to work that out? Well, it's going to be the same as this one here. So if I draw the triangle on the left out, if that's 62, that's X, that's 5. I've got a right angled triangle. This one is going to be SOHCAHTOA. So label it up: hypotenuse, opposite, adjacent. I've got the adjacent. I'm trying to work out the opposite. So I'm going to do tan of my angle equals opposite over adjacent. Multiply both sides by 5. And I get 5 tan 62. So 5 tan 62. I get an answer of 9.4036323 and so on. Now it's important I keep that whole number because it's not my final answer. So that length there is the same as that one there. So if I draw my right angled triangle on the right hand side, this length we've worked out is 9.4 and so on. This hypotenuse is h, and we need to work out x. Again, it's going to be trigonometry, so the hypotenuse and the opposite and the adjacent. I've this time got opposite and the hypotenuse. So I can do sine of my angle equals 9.4036 blah 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 over 12. And to work out x, to work out an angle, you need to do sine to the -1. So do blah 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 blah. Type that into your calculator. How do you get sine to the -1? Well, what you need to do, so I've got that answer there, as you can see. I do shift sine, so you can see that I've got sine to the -1. I'm then going to have my fraction. Now I've got that previous answer saved in my calculator, so I don't need to type out all of the digits. I'm dividing it by 12. I need to make sure I close the brackets, and then I've got my answer, right? So let me just take away so you don't have the massive reflection. So we've got x equals 51.5, and then what does it say? Is it an 8 or a 9? 5, 9, blah, 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 blah. And in fact, it doesn't tell us to give it to a certain number of decimal places, so I'm just going to say 51.6 degrees to 1 decimal place. I only round right at the end of my calculation. Okay, that was a pain, wasn't it? I ended up speaking for ages on that one. Number 19. So, number 19, let's write this out. 7a plus 2b minus 3a all over 8a plus 6b plus 2a minus b. People are going to look at this question and go, I have a clue what I'm doing. Well, have a go. What could you do? There'd be year 7s that could do some of this stuff in terms of looking at that. What can we do? You've got to back yourself. So 7a take away 3a is just going to be 4a. So on the numerator we've got 4a add 2b. And what are we going to do at the bottom? Well, we've got 8a add 2a is 10a. And then we've got 6b take away b, which is 5b. Right? It's really important that you get the sign in front of the terms that you've got. Okay? So we've got, let's just write it down here, 4a plus 2b. And then we've got 10a plus 5b. Well, they don't look the same. So what you've got to spot is that you can factorise the top and the bottom. So what's the biggest number that goes into 4 and 2? Well, that's going to be 2. So we've got 2 lots of 2a plus b. What's the biggest number that goes into 5 and 10? Well, 5. And if you factorise that, you should get 2a plus b. So we can kind of see what's happening now. And anything divided by itself is just 1. So we can cancel it. So whatever values of a and b you put into this fraction, you will always end up with 2/5. So that is all you need to do for that question. All right, so simplifying the like terms at the top, you've then got to be able to spot to factorise it. There's nothing else you can really do with it, to be fair. So you've got to factorise it, and then you can see that those two bits are the same. So you can go from there. Right, which one are we on now? Oh, what have we got here? So, question number 20. A, B, B, C, C, D, blah, 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 are all, okay, that's important. They're all part of a regular decagon. Regular, meaning that all the angles and all of the sides are the same. Decagon, meaning that it's a 10-sided shape. Okay. In fact, let's work that out at the beginning. So it's going to be angles. We want to work out interior angles. So how do you work out the interior angles, what they all add up to for a 10-sided shape? Well, the formula is number of sides take away 2 multiplied by 180. So for a 10-sided shape, we're going to do 10 take away 2 times 180, and then we're going to work that out. So 8 times 180 is 1,440 degrees. So that's what all of them added up is. Now, because it's regular, that's important, all of the angles must be the same. So actually, one of the angles in the regular decagon is just going to be 144 degrees. So if I draw this out, hopefully it kind of looks similar, probably doesn't. So we've got something like that, A, B, C, D, E. Which ones are actually the proper angles inside a decagon? Well, it's going to be this one, this one, this one. And we know that these two angles are the same. So we've got 3 times 144. So let's just work that out. So 3 times 144. 3 times 144 is 432. Have we got a 10-sided shape? No, we haven't. We've got 1, 2, 3, 4, 5 sides. So n minus 2 times 180 for a 5-sided shape is going to be 540 degrees. We've already got 430 degrees, so 540 subtract 432 is going to be 108 degrees. And we need to divide it between these two angles. Now, fortunately for us, they're both the same. So we can just do 108 divided by 2. Each angle must be 54 degrees. And that's all we've got to do for that question. We don't need to do anything else. Right, 21a. So 21a. Circle the point on the graph that's on y equals 1 over x. So a lot of people don't understand that this actually has to work for the coordinates. That's the whole point. So if we've got the first one, minus 1, 1, the x coordinate's the first number, the y coordinate's the second number. So would that work if I substituted it in? 1 equals 1 over minus 1. No, that one doesn't work. Next one is 0.33. 3 equals 1 over 0.3. Type that into your calculator. That one doesn't work. What about 0.8, 0.2? So 0.2 equals 1 over 0.8. Again, that one doesn't work. And then if you do 2.5, 0.4, if you do 0.4 equals 1 over 2.5, that does work. So we've got our answer. Okay, 21b. We have an exponential graph. Here is his graph. Make one criticism for 1 mark. So we've got y equals 2 to the power of x. Now, in previous videos, I've said that anything to the power of 0 is 1. So 2 to the power of 0 must be 1. So when x is 0, is it 1? Yes. 2 to the power of 1 is 2. That's correct. 2 to the power of 2 is 4. That's correct. 2 to the power of 3 is 8. That's correct. 2 to the power of 4 is 16. No. Okay, they've plotted it at 15. So make one criticism. Should be, you could put should be for 16. And they have plotted for 15. Something like that. Okay, so you've just got to check those coordinates. It looks okay, but they've just plotted one of the points incorrectly. Okay, 22, you just need to know what the sine graph looks like and then be able to do some translations with it. So we've got the sine graph goes between 1 and minus 1, if that's 0. And the sine graph just goes like this. Okay, it just keeps going and going and going. So we've got 90, 180, 270, and 360, and it just keeps going and going and going. Now we've got the graph of 1 add sine x. So all of this just needs to be added 1. Or we just need to add 1 to all of our values. So here it starts at 0. It's actually going to start at 1. And we're just going to shift the whole thing up. So what is our graph going to be? It's going to be A. Okay, so we're just starting at 1. 23. Oh, wow, 4 marks. How am I going to be able to finish it on this piece of paper, I wonder? So we've got a triangular prism like so. Like this, and then it goes to the midpoint like that. That's 5. That's 12. That length is 16. Work out the volume. Okay, so the volume of a prism. Prism just means that wherever you chop it, the cross section, the end is the same. So this looks like kind of like a Toblerone bar or something. Wherever you chop that, the triangle is always going to be the same. If you had a Pringles tube, wherever you chop the Pringles tube, it's always got the same circle, right? So those are both prisms. And the volume of a prism is the area of the cross section times by the length. Now in this case it's a triangle, half the base times the height. Well, we've got the base and the height, so the area of this bit is easy. I'm happy with that, but I need to work out the length. So how am I going to work out the length? Well, M is the midpoint, so I need to work out this length, and then I'm going to double it. So if I've got that length, this is a right angle here. I need to work out that one, and in order to work that one out, I need to know this length. So if I deal with the end, you've got 5, then you've got 12. I have two sides. I'm trying to work out a third, so it's Pythagoras. And again, if that doesn't make sense, have a look at, I've got a triangle, but I don't know what on earth to do. It's going to be a squared plus b squared equals h squared. In this case, we've got 5 squared add 12 squared equals x squared. Simplify that down. You get x is the square root of 169, which is 13. So then looking at this triangle here, we've just worked out that that one is 13. So if I draw it over here, that's 13, that's 16. We want to work out, let's call that, I don't know, y. Again, we have two sides. I'm trying to work out a third. So a squared plus b squared equals h squared. This time we've got the hypotenuse, so let's put 13 squared add y squared equals 16 squared. Simply rearrange this, plug some numbers into your calculator. So 16 squared minus 13 squared is 87, so y squared is 87. So y is the square root of 87, which is 9. Oh wow. Okay, so square root of 87. In fact, what we're going to do, because this is going to get quite messy, so if halfway is root 87, then that one's also going to be root 87. So what I'm going to say is I'm going to say the length is 2 root 87, right? And I'm running out of room. So the length is 2 root 87. And the question says work out the volume of the prism. Let's see if I can just squeeze it in here. So the volume, as we said, was the area of the cross section. So half times the base times the height. And we need to times it by our length, which I've worked out is 2 root 87. So if I just type that into my calculator, so I've got a half times 12 times 5 times 2 root 87, you should get 60 root 87. Do they want it as a decimal? No. So you could actually, if you're feeling bold, just leave it as 60 root 87 centimeters cubed. If some of you are just having a panic because you've never seen something like that before, you could just say, okay, right, well, let's just put it as 559.6 centimeters cubed to 1 decimal place. Okay, so there's quite a lot of work to do with that. 2 lots of Pythagoras gets you halfway. Double it to work out the length, and then use that knowledge of volume of a prism, area of the cross section times by the length gives you that volume. Right, 24. So let's have a look at 24. Again, this one's probably going to be a bit difficult without the paper printed, but let me see if I can explain it to you. So you've got your axes like so, and you've got your shape that looks like that. Okay, so it's not great, but you get hopefully the idea. And we're rotating it 90 degrees clockwise about 0. So what I would suggest is that you get tracing paper in your exam where you ask for it. Put your tracing paper over your shape and draw a vertical line anywhere. Let's just draw it here for now. Okay, facing north. Now we're rotating it about 0, and 0 is the origin here. So what I would suggest is that you put your pen on the origin and think, well, okay, if I'm rotating it 90 degrees clockwise, if you don't know which way a clock goes, just look at the clock in your exam, right? It goes that way. So 90 degrees clockwise, I need to turn it until my arrow is facing that way. It's just kind of like an idiot-proof way of doing it. So actually, if I can try and do this in my head, kind of visualizing it, I think you end up with a shape that looks something like that. And we're looking at what is the coordinate of point C, and then we need to do something else with it. So I think, let me just try and work this out. So I think that if you rotate it, what on earth are we going to end up with here? I think if you rotate it, and I could have got this wrong, it's going to be 1 minus 4. I think that point there is going to be 1 minus 4. But then what we need to do is we need to translate it by this vector here. And again, vectors, the top number is left or right, and the bottom number is up or down. So minus 6 is going to go 6 left. So if we're on 1 take away 6 is going to be minus 5. And if we're on minus 4 and we're going up 2, then we're going to go up to minus 2. And that's how you should do that one. In fact, that's only 24A. What are they asking us to do for the next one? 24, that was 24A. 24B. Triangle PQR is shown when PQR is reflected. Okay. This one, again, you just need to know what the words mean. Invariant means doesn't change. Right? Doesn't vary, doesn't change. So we've got a shape. Let me just draw it out. Okay, so we've got a shape here. PRQ. I reflect it. So I put a mirror somewhere on this diagram. And I'm going to flip the shape. I'm reflecting the shape. But P and R don't change. They're staying in the same position. They stay there and there. So what you should realise is that the only place the mirror can go is actually on that diagonal line there. So you need to know what that equation is. And if you don't know, just pick some random coordinates. Right? Just pick P and R or whatever the coordinates are. And what you'll see is that you've got minus 4, 4, minus 3, 3, minus 2, 2, and so on. So the y value is equal to the minus of the x value. And that's the equation of your straight line. Okay, so y equals minus x. And actually, what I would recommend is that at GCSE, they kind of only expect you to know these kind of main diagonals. So this one here is y equals x. And this one here is y equals minus x. That's useful to know if you don't already. Right, 25. So 25, we've got 3x squared plus 11x minus 20. Right, well, there's different ways to do this. There are some procedures, but it's also, I think, important to understand what you're doing, because then it kind of makes it easier in the long run. So in the same way as you would do it if you just had 1x squared, so write out the factors of 20. So 1 and 20, 2 and 10, 4 and 5. We need, because we've got 3x squared, our brackets are going to be 3x and 1x. So we need 3 lots of one of the numbers and 1 lot of the other to give me 11. So have a think, 3 lots of one of the numbers and 1 lot of the other to give me 11. One of them must be negative because I've got a minus 20. And what you should see is that you've got 3 lots of 5 is 15. And then you want to take away the 4. And that's going to give you 11. Because I want 3 lots of 5, it needs to go in the opposite bracket. So 3 lots of 5 is 15. I want to take away 4. So that's going to be what my final answer is. And if you wanted to check, you can just quickly expand it. Right? Oh, I'm not really sure if I've got it correct. So let's just expand it. So we've got 3x squared minus 4x. 15x take away 4x is 11x. So I'm happy with that. And then we've got minus 20. So I'm happy that I've got that one correct. All right, so expanding, factorising, they're just the opposites of one another. Okay, 26. Edith's van can carry a maximum load, so max load is 920 kilograms. She wants to use her van to carry 30 sacks of potatoes, and it's 25 kilograms to the nearest kilogram. Okay, so when they say nearest kilogram, it's upper and lower bounds. Right, straightforward. You've just got to spot what nearest is, and then you can just work it out. So nearest kilogram, that means that we're starting with 25, and we're just going to go up and down in kilograms. Right, halfway between that, halfway between that. So we've got 24.5 and 25.5. And we need 30 bags of that. So that's 30 sacks of potatoes, right? And then we've got 20 sacks of carrots. And that's 7.5 kilograms, but to 1 decimal place. So in this one, it was to the nearest kilogram. So I just went up and down in kilograms. This one's to the nearest decimal place. So I'm just going to go up and down in decimal place, like 1 decimal place. Again, halfway between these two. Hopefully you can spot that that's 7.45 and that's 7.55. And if you can't, just add a 0 to each of these. And then hopefully that makes it a bit easier. What's in between 40 and 50? 45, 50 and 60, 55 and so on. Work out, can she definitely use her van? Well, to make sure that she can definitely use it, we need the heaviest that they can be, right? So 30 bags of potatoes, 30 times the heaviest that each bag could be, 30 times 25.5 is 765, sorry I've got pounds, it's kilograms. And she wants 20 lots of 7.55, which is 151 kilograms. So add that with the previous answer of 765. The maximum weight is 916 kilograms. She can take 920 kilograms, but the question says, can she definitely use her van? So you must answer the question, yes, she can. Okay, 27. And then we've got 20 discs in a bag. And we need to work out, 2 of the discs are taken at random from the bag, work out the probability that the first disc is a smaller number than the second disc. So what I'm going to try and do, and I don't know if this will help you or not, but what I'm going to do is I'm going to say, well, these are the 4 numbers that I could take from the first pick, right? So what's the probability I pick an 11? Well, I've got 4 out of 20. What's the probability that I would pick a 22? Well, that's going to be 6 out of 20. There are 733, so that's going to be 7 out of 20. And then we've got 3 out of 20 as the probability for choosing a number 4. Now, this is where you've just got to think. So if I get an 11, it says work out the probability that the first disc has a smaller number. Okay, well, all of them are bigger than 11, aren't they? So how many are bigger than 11? Well, if there's 4 11s, then there must be 16 other ones. But because I've already picked out an 11, my total is now out of 19. Now, what about if I get a 22? Well, what probabilities or what numbers are bigger than that? Well, it's the 33s and the 44s. So that's going to be 7, 8, 9, 10 out of 19. Numbers bigger than 33 is only the 44. So that's going to be 3 out of 19. And then, in fact, there is 0 bigger than 44, right? Because 44 is the biggest. Now, with tree diagrams, if you go along the branches, you multiply them. So the probability here is going to be 4 out of 20 times 16 over 19, which is 64 over 380. This one is going to be 6 over 20 times 10 over 19, so that's going to be 60 over 380. This one's going to be 7 over 20 times 3 over 19, which is going to be 21 over 380. And for the final one, because we're timesing it by 0 in effect, then this answer is just going to be 0. So I'm just not going to write it. It's just going to be nothing. So with tree diagrams, going across the branches you multiply, but because these are all probabilities where actually the case would be true, then I just need to add these at the end. So what I'm going to do is I'm going to do 64 over 380 plus 60 over 380 plus 21 over 380. And that gives me 124, 145 over 380. So hopefully that makes sense. I've kind of done like a weird kind of tree diagram, but I hope you kind of get the general gist of what I've tried to do. Okay, number 28 then. So we've got, I think, 2 more to go. So 28. We've got a speed time graph. Now, I think I've gone through this in a previous video, but basically with this, say you've got a distance time graph, then we've got a velocity time graph, then we've got an acceleration time graph. They're called kinematic graphs. So if we work out the gradient of a distance time graph, we get the velocity. And if we work out the gradient of that, so if we work out the gradient of the velocity time graph, we get the acceleration. And then going the other way, we work out the distance. So if we've got a speed time graph, a velocity time graph, the area underneath the graph is going to give us the distance. If we've got an acceleration time graph, the area underneath is going to give us the velocity, and so on. So here we've got a speed time graph. So we've got a speed time graph, and we are working out a distance. So I need to work out the area under the shape, and I need that area to equal 75 meters. So we've got meters per second, and then we've got seconds. So our shape looks something like this. And we go up to 10 here, so that's our velocity, and then that's our time. So you should see that we've got a kind of triangle and then a rectangle. So let's start by working out the area of the triangle. So the area of the triangle, well, it's 4 wide and it goes up to 10, doesn't it? So the area of a triangle is half times the base times the height. Half of 4 times 10 is going to be 20 meters. So that's fine, but we want to go a distance of 75 meters. So 75 meters subtract 20 meters is obviously 55 meters. Now we've got like a kind of endless rectangle, haven't we? So we don't know where exactly we're going to stop this. Let me just zoom out a bit. Okay, so the kind of top bit is at 10, isn't it? So we know that the kind of height of our rectangle must be 10, but we only want to get 55. So what do I need to multiply by here to get 55? Well, you should hopefully see that you're going to do 55 divided by 10. So x is going to be 5.5 seconds in this example, because we're going along this kind of axis here, aren't we? So how many seconds was it at the base of the triangle? 4. And how many seconds have we had to go along this rectangle? 5.5. So my overall time then for 75 meters, if we add those together, should be 9.5 seconds. All right, so that's how you do that one. Right then, the final question is a bit of a beast, I'll be honest with you. So bear with, and let's have a look to see if we can do this one. So we've got 5 over 4x plus 1 is equal to 2x over x squared plus 3. Now when we've got these fractions here, we're going to cross multiply. Okay, so we're going to multiply the left hand side by this denominator, and we're going to multiply the right hand side by the other denominator. So we get 5 lots of x squared plus 3 is equal to 2x brackets 4x plus 1. Expanding this out, we get 5x squared plus 15 equals 8x squared plus 2x. Now we've got an x squared on both sides. Now we want x squared. It's kind of easier to keep the x squareds positive. So can you see that if I take away 8 from 5, it's going to become negative. Whereas if I take away 5 from 8, that's still going to give me a positive. So what I'm going to do is I'm going to take away the smaller x squared. So I've got 15 equals 3x squared plus 2x. And we've got a quadratic, so the highest power of x is 2. So we've got what's called a quadratic. And a lot of the times they want you to make it, or in fact, once you've got a quadratic like this, how do you solve it? Well, it must equal 0. And ours equals 15. So how do I get to 0? Well, I'm just going to have to take 15 away from both sides. So you get something that looks like this, right? Now, usually they just write it the other way. I prefer it that way. It doesn't make any difference. But let's just write it this way, just because I prefer doing it. Now, the key here, so once you've got a quadratic, you could see if you could factorize it, right? So we've done a question like that previously. However, they kind of give you a clue. They say give your solutions to 3 significant figures. So if they ever say that and you've got a quadratic, so round it to 2 significant figures or give your answer to 2 decimal places, for example, they are probably telling you to use the quadratic formula. So I'm just going to make that assumption that in this case, we are going to need the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. right? That's the hardest bit about this. You just got to kind of learn that formula off by heart. Now with a quadratic, you've got ax squared plus bx plus c. So a is the number in front of x squared. So we've got a is 3, b is the number in front of x, which in this case is plus 2, and c is this number here. So we've got minus 15. Now what you can do, if you've got a good calculator, it's okay actually, right? So all we're going to do is we're just going to substitute these values into this formula. Now the trick is wherever you've got a letter, put brackets around it when you put it into your calculator. And then instead of what's that letter, so for example B here, just put in whatever B is. So let me show you what I mean. So we've got minus B plus or minus the square root of b squared minus 4 brackets a brackets c, all divided by 2 lots of a. So can you see, wherever I've had a letter, I've just put it simply, I've just substitute that value instead of that letter. And then if you've got yourself a decent calculator, you literally just type that whole thing in. So I'm gonna have my fraction. I'm going to include all of my brackets. So I've got minus 2. The first one I'm going to do is plus. So minus 2 plus 2 squared minus 4. I don't even need to put times. I'm just going to literally just put whatever I've written into this calculator. So I've got all over 2a. And I'm hoping that I've done this correct. I haven't checked. I'm going to assume that I've got that one correct. Okay, so when we use the plus, so when we do the plus, we get an answer of minus 1 plus root 46 over 3. Now ordinarily that would be okay, but they've asked us to give it to 3 significant figures, so I'm going to say this one is 1.93. But there are 2 solutions, so rather than having to type it out, we did the plus. Rather than typing it all out again, I'm just going to use the cursor and I'm going to see if I can go back to the plus, and I'm just going to swap it for a minus. And again, so this one you get minus 1 plus root 46 over 3. But again, we want it to 3 significant figures. So it's going to be minus 2.59. I hope that's useful. Again, kind of learn that quadratic formula off by heart. Make sure you put brackets around the letters and just substitute those values in, and you can't go wrong. If you've not got a decent calculator, I've got a link to one that might be useful in the description of the video. There are plenty out there, but you want to get a decent, proper scientific calculator. Right, that was an absolute beast of a paper. It took me a while. I hope it's useful. If it is, share it with your friends, like it. Subscribe so you know when another video is out, and I hope you have a brilliant rest of the day.